Hello, my name is Dan Vogt. I'm the engineer here at Bioptechs, and I'm going to introduce you to a system that we developed here for a customer that needed to observe worm embryos and temperature transitions for those worm embryos on a microscope. The scope they're using is using high numeric aperture objectives, therefore they needed to have a cover slip surface and a very rapid temperature change capability for the specimen at the specimen plane. The way we've done this is to set up two nanotherm systems. The nanotherm system, as I'm showing here, is a Peltier-driven device with a fluid reservoir and a recirculating pump, all together under the control of a digital processor. This allows you to set the temperature that you want in the fluid flowing from and to the system into a separate device. In this case is our little worm embryo chamber. Now we're using two nanotherms, therefore the temperature on each can be set separately. The flows from each of these individual nanotherms goes through a little network of relays where the fluid flowing from temperature source A, for instance, will pass through the worm embryo chamber and then back to itself to maintain recirculation. All the time, the second nanotherm, which has to remain running for your second temperature source, is also short-cycled through the solenoids to allow this system to continually recycle and maintain its stable temperature. Now I'm going to turn these on. It's going to make a little bit of noise, but I will show you how it switches back and forth. I'll take a second to boot up. Over here is a power supply that the solenoids plug into, and you'll see when we throw the active knob on here, energizes all the solenoids, and that causes the flow to go from this nanotherm through the device instantly from this nanotherm through the device, and then it'll turn around and short cycle back into the first nanotherm. So in other words, whichever nanotherm is feeding the embryo chamber, the other one gets short-cycled. In order to accommodate the high numeric aperture objective, the specimen is going to have to be placed onto a cover slip. Now here we have a 30 millimeter number 1.5 Dassault 263 cover slip. This cover slip sits into a Bioptechs ICD, stands for Interchangeable Cover Slip Dish. The cover slip simply rests in the bottom of the dish, and then an autoclavable polycarbonate O-ring sealed sleeve then screws down on top of the cover slip so that you've now made a chamber, basically. Now this is the device that we will be placing the worm embryo holder into. Once the embryo is placed on top of the auger pad, this device is simply turned upside down with the embryo on it and placed inside the ICD. Now you have the embryo with the auger pad behind it directly pressed up against the cover slip and ready to sit into the microscope stage. By simply activating the solenoids, we're now going to change the flow of refrigerant from source A to source B. Now you'll see in the graph how quickly this transition can occur. It's roughly 20 seconds you have 90-some% of the transition complete.